I will show you 7 different examples, and hopefully you will understand how it really works. So this is the our homepage. As you know, let's click one of the pipeline. As you can see, these bigger circles represent our processes, and there are 2 types of smaller circles. One of them is called, the orange ones are called input parameters. This means that this parameter will be asked to user in the run page. So whenever you drag and drop this input parameter to this page, this parameter will be asked to user in the run page. And there are other types of circles. They are called output parameters. Again, you can drag and drop from over here. And you can specify by using these boxes, you can specify the report section. You can send the output of the multi-QC to this report section. So let's look at a little bit simpler version of the pipeline. Now we have only one input, one output, and only one process. And if we click the settings icon on top of it, this window will show up. So at the top, it shows its name, process name, and it shows its menu group, which is located in the left sidebar. You can see there's a parameter box. So you can define new parameters by using this tool, this section. And also we have this input section. Since this is only one input, you can see that we have only one input in this field. And also we have output section like this. And finally, we have a script section. So we just want you to focus on this only one process. You can add multiple scripts into this process, but this overall isolates the execution of one main task in a one process. So what it does actually, after we are entering these sections, we are parsing these data and we create this Nextflow script. And we are actually executing this Nextflow script in the backend. So let's see how this drag and drop interface works. This is a short tutorial that explains how it works. So you can drag and drop these input and output parameters into this section. You can edit these names like this. You can search any process that you want. And again, you can drag and drop into this place. Again, output parameter like this. So if you want to connect these nodes, just click each of the nodes like this. It will create an edge. So you can rename output parameter. You can choose the publishing type. You can specify whether if it is text, you can show it as a text file, or if it is the kind of TSV format, you can choose data tables format, R Markdown, DE browser format. There are lots of options available over here. So after drag and drop, you can click and move those circles really easily. Yeah, that's how it works. Let's talk about our building blocks. So we already little bit discussed about this section. We have inputs, outputs, and script section. And while defining these inputs and outputs, we have different set of blocks. Over here, we need to define a kind of a building block over here. And we have only 3 different building blocks to use. The simplest one is called val, where you can simply define a kind of a string or integer and transfer those values within this system, this block. File block is really simple as it sounds. It's used for transferring the files itself. And the set is a little bit complicated, since if you want to use multiple blocks in a one system, we call it set. So if you want to transfer one val and two files or one file in one box, we will call it a set. So in this example over here, it has one val block in it, and also it has one file. And it's in a kind of a square brackets that it says that it's kind of a block. So let's talk about our input parameters. These input circles work like a factory to create these kind of building blocks. So let's look at this simple example pipeline. So it will start with this building block. It's a file block, for example, over here. The reason that it's created a file block is behind of this process. Since we define this first input parameter as a file block, this input parameter created a file block in this example. So again, this block will be transferred to the process. This will be executed like this, and new block will be created. Since we defined this output as again the file block, the output is created in a file format. Let's send this block to the next process, execute them. Now we created set block, for example. If we specify that this output is in a set format, it will create as a set. So let's talk about adding new parameters. While you are creating your process, we have this section called parameters. If you click this parameters add parameter box, this add new parameter window will show up, where you can define identifiers, qualifiers, or the file type. So let's talk about those fields. The identifier is really straightforward. You just give a name for those parameters. And you're gonna choose the qualifier. Again, this means choosing the building block that we are talking about. You can choose val, file, or set. And for the val type, we don't have this file type field. Instead, we are using this identifier value for this case. The reason that we are actually using this file type, it's related to our user interface. So let's see over here an example. So now I just hover one of the outputs over here. So you can see that it shows me the available connectable nodes in the interface. You can see that these dots are kind of smaller, which means that you cannot connect this node with these nodes or this node, since their file type is different. Only this file type is the same, so you can easily connect those. So in order to connect our nodes like this, we are checking this file type field over here for file and set. For val, we are checking the identifier name. So you can only connect input text with input text. And so you can click these nodes like this to create edges. Let's check this example. Over here, as you can see, there is no available node that you can connect right now. It's in a TSV format, and there is no process that accepts TSV file. Let's look at the other example. I can simply connect these nodes like this. Okay. So when you create these parameters, while adding your inputs, it will look like this. So since you created input text in a val format, it will show up like this, input text, and in the parentheses, there's a qualifier as well. And for the file, again, you have the similar structure, but the first thing that it shows is the file type. Again, for the set is very much the same thing. Next, over here we have this variable section that you can define. So since we transfer these blocks to this input system, we will assign those values into a variable. So we can simply use these variables in the script. So these two are the simple examples of a variable. And for the set type, it's a little bit looking complicated since it might have more than one variable. So the first variable in val format, so we encapsulate it with the parentheses, and we are telling them that this is coming from a val type, and this is coming from a file type. So since this set might contain more than one block, we can use this notation for these purposes. Okay, so now let's start creating one simplest pipeline to understand how actually it works. So I'm going to use this val block right now. And the reason that this val block is created, again, it's because of this input parameter. So this input is created in a val format. That's why this block created in a val format. So as we already talked about, as soon as you created this input parameter in the workflow, this parameter will be asked the user to enter. As an example, I just entered very simple text like hello world. And this hello world is transferred into this val block like this. And when it comes to this execution step, we assign this hello world into this text variable. And when it comes to the execution, it goes to this script section, and we use this text variable in this script section. And since it is a variable, it's a really common thing in the bash, you add this $sign as a prefix. So this means that actually you are running this command with this format. So you are actually replacing this $text with the actual value, like hello world, and execute this command. So let's execute this process. It will create this example.txt file. And now we want to define this output node. How we can define this output node is using this pattern in this field. So again, we choose this output format as a txt file. It's in a file block format, and the file type is txt. And as a pattern, I entered this example.txt. So it will match, it will try to find this example.txt as an output, and it will create this block, this file block, and it will send to the next process, or in this case, it's going to just publish to our reports. So how it look like in the run logs is very much the simple thing. It's just executed one process. It's called echo while, which is the name of this process. And this is executed in one of the subdirectories in your run folder. And at the end, it published this example.txt file. And it just had this hello world. Let's talk about file block right now. Instead of using val, now I choose to use a file block. And I define this input as a file block like this. So user defined this file as a full path like this. It's on a single file, and it entered the full path like this. And our tool is created this file block, very much similar to the previous examples. Let's go to the execution step. Again, now we can use this read variable, which matches to this name of the file. We can use in the script section. So you might remember this command. We already talked about while we are counting the amount of the reads, and we save this value into a count.txt file. So the actual command that it is executed in this example is like this. Our editor gonna replace this read variable with this control underscore rep1.fastq like this. It will count this value and save into a count.txt. So after execution, it will create this count.txt file. And again, we will use this count.txt pattern to set our output channel. So you might ask, why did I use these codes? Maybe you realize that we didn't use any codes over here, but over here we are using codes. The reason behind this is a variable, and we don't need to use any codes while defining variables. On the other hand, in this section, it's not a variable. We are just defining a pattern. So we need to use these codes in this section. So let's have a look at their logs and reports. It just printed the amount of the reads in this count.txt file. Now let's make it a little bit complicated. We are gonna use more than one reads. Before we just use only one read, but now it's gonna be on 3 files, 3 single end reads like this. So how it's gonna work? Let's see. We will execute the same command. So since we are executing these all processes in parallel, all these processes gonna create this count.txt file. So since we give the name like this, all these processes gonna create this count.txt file. And when you publish this into a count folder, you can see that only one count.txt file is gonna be published. Since they all run asynchronously, they overwrite each other's results. So that's a problem that we need to solve. So how we can solve this problem? Basically, we need to give a kind of a variable in this output file. So let's check our solution. Over here, since this read has this name, which belongs to that file name, control underscore rep1.fastq, you can use this overall name in the output file name as well. So over here, you can see that I choose to use this curly brackets for the reads. Both are the same thing, but if you are using the variable with the other string just next to it, you need to use this curly brackets to isolate the variable. And if you check the actual executed script behind, you can see that this control rep1 fastq.count.txt is going to be created. So let's execute this pipeline, and you can see that all these different file names are created right now. So for the output section, I cannot directly use only one of the names for now. I cannot say count.txt, for example. I can use these glob patterns or regular expressions to explain this pattern that I created. For all of those outputs, for all of these outputs, if our tool is just looking for this pattern, this star means that any kind of character could it be possible in this region. We can simply match all these reads, all these outputs by using this pattern. And we can publish these files like this. So we run 3 processes in parallel, and we created 3 files like this, and none of them overwrite each other. So it's look okay, but the thing is, file output name doesn't look like very clean. So it has all the name, and we added this suffix at the end. It doesn't look like very much clean. Let's look at our different block type using set. And this will help us to create a little bit simpler script. So when I use set as an input block, now the next flow gonna create me this block, and it's gonna create me automatically actually. So it will send me first of all the file name and the file itself. It's not just gonna be the file, it will have this base name of the file as well. So this will make my life a little bit easier. So while defining these inputs, now I can match this name section with this while parentheses name, and this file with the file parentheses read. By the way, you can define any kind of variable names over here. You can call it name or any name, it doesn't matter. The only thing is you're gonna use in this variable in this section, in the script section. So let's have a look how our script is changed. So this part is again the same, only the output part is changed. So we use this name over here, which is the base name of this file. And now for output, I can use this variable as well. I can use this dollar and curly brackets name to define this output as well. This is a different convention. I could use star.txt as well. And as you can see, these outputs looks very much cleaner and the results very much the same. What if we want to use these paired reads in our system? And then we will need to define one more parameters, which is called mate. If we define mate in this process, if we just insert the input parameter called mate, it will accept two types of reads. It could be only in a paired structure or the single structure. You can specify by using this drop down. So if it is defined as pair, the next flow will create this pattern for us. So it will have this base name at the beginning. Then first forward read and the reverse read will be listed afterwards. So how it's gonna work in our script section? Let's check our script. Over here, we executed the same script again. We didn't change anything. We only added this mate parameter. And now for the read variable, we received two of the files, R1 and R2 at the same time. So the command is look like this, WCL, both of the files, and we count those files and print it into this file. So let's execute this code like this. Again, I didn't change the output pattern. And let's have a look at the run reports. For the control rep one, I can see that there's 3 lines. The first 2 lines are the just read counts for each file, but this is look weird. This is the total amount. The reason behind that we are getting this third line is this. If you execute a WCL command with just one file, it will just print only one file's count value. But if you use multiple files like this, at the end, WCL prints this total value. So actually, you don't want to see this total value in this report, right? So you just want to see only 2 reads report. So how we can deal with these instances? So we need to actually define a conditional script. So let's check another example. Over here, I just changed the script section. So I inserted a condition like this. So based on this mate parameter over here, if it is in a pair format, I will do the same command, but at the end I execute this head dash 2 to get only the first 2 lines of the script. The other part, if it is in a single form, I will execute the command as it is. I'm not going to change. This is the conditional system actually allow me to execute my command based on the selected reads. And you can see that I changed this awk command a little bit. I wanted to keep this file name as well. And we get rid of this third line. The total amount of the reads are removed. So let's have a look for the single read section. So we choose this as a single and we use 3 single end reads. Now we just get only one of the outputs since we don't need to remove any kind of thing. And let's merge all these results in a single consolidated table. Again, we do this operation all the time to create consolidated tables for the report section. So again, we start with this paired structure. We do this count read operation. We created those files that it saves these count values in these files. Now we're gonna merge those files in a single file. In order to do this, I need to do some operation in this input field. I'm gonna click this settings icon and I will choose this collect operator. There are a bunch of operators available in this tool, about 50 different operators that you can use. And now this variable will contain all the files that we consolidated. So this files will be, this txt files code will be replaced by these 3 files. So I can easily merge those files into a single file. In the script section, you can see that we inserted a header at first, file name, tab, and count as a header. Then I just kept those values inside of those tables and embedded into this count.tsv file. So let's run this pipeline. It's created our counts.tsv. We match with this pattern. And let's have a look at these run logs. As you can see, these 3 count read process executed in parallel, but at the end, only one merge tables process is executed. So all these files are transferred into one of these blocks and executed as a one process. And at the end, you can see that you have a consolidated table for each file name. You have a count value. Regarding to these operators, we have a lot of options available. If you go to Nextflow documentation, you can see their explanations about their 50 different operators. And I would like to finally just summarize what we have done for all these times. For the first example, we use val block to just create an example.txt file, and it just has this value, hello world. And for the second example, we counted this read amount in the file, and we created this count reads table, but we didn't like the name, so we go to the set format. And we executed this conditional script, and we created this actually clean, perfect values like this. Finally, we use collect operator to merge all these results in a single table. And next step is gonna be building a pipeline. So we have as we already talked about, we have this tutorial. You can go through this tutorial and we will be on the Slack to help you out